Bismillahirrahmanirrahim. Hello everyone. Welcome back to the another tutorial of control system MCQs. So the first MCQs is, what is the order of a closed loop control system for a plant with a transfer function equal to Gs is equal to Ks divided by S square 1 plus Ts and with unity feedback 3, 2, 1 and 0. So the transfer function is given to me, that is equal to K divided by S square into 1 plus Ts. So the every transfer function in a control system has a specific types and orders. So the transient state depend on the order of the control system, and this order is obtained from the closed loop transfer function. And the order of the closed loop transfer function can be found from the highest power of the characteristic equation. So here in this transfer function, the characteristic equation is this. So this is your characteristic equation. And the highest power of S is here, that will be S square plus Ts cube. So the highest power is cube. So this is order 3. So option A is the correct answer. Okay, next MCQs is, a second order control system is defined by the following equation. So equation is given to me, that is 4d square ct divided by dt square plus 8d ct divided by dt plus 16 ct, that's equal to 16 ut. So as we know that S is equal to d by dt, so this will be equal to 4 s square like c s plus 8 s into cs plus 16 cs is equal to 16 us. So your cs by us, that will be equal to 16 divided by 4s square plus 8s plus 16. And if you simplify it, so that's equal to 4 divided by s square plus 2s plus 4, 2 and 2. Okay, now we need to find the omega zeta, and zeta is your damping ratio. So 2s is equal to 2, here we have s. So 2 will be equal to 2 zeta omega n. So this 2 will cut out by this 2. And your zeta is equal to 1 by omega n, and omega n is 2. So that is 0.5. Yes, so option C is the correct answer. Okay, next MCQs is, the steady state error due to RAM input for a type 2 system is equal to, so that is equal to 0. So option A is the correct answer. Okay, next MCQs is, differentiation of parabolic response is a dash response. So actually the parabolic response is RT, that is equal to A times T square divided by 2. So now taking differentiation, that will be d by dt RT, and here we get 2 times A times T divided by 2. So this 2 will cut out by this 2, so the answer will be equal to A times T. So this is, which is the ramp function. So your differentiation of parabolic response give us ramp response, and differentiation of ramp response give us step response. And differentiation of step response give us impulse response. Okay, so differentiation of parabolic response is a ramp response. So the correct option is option B. Okay, next MCQs is weighting function is in terms of, so actually the Laplace transform of impulse function give us the transform function. So the transform function in terms of the Laplace transform of impulse response is known as the weighting function. So weighting function is in terms of Laplace transform of step response? No. Laplace transform of a ramp response? No. Laplace transform of a parabolic response? No. Laplace transform of an impulse response? So option D is the correct answer. Okay, next MCQs is the impulse response of a system is given to you, and that is Ct is equal to minus t e to the power minus t plus 2 e to the power minus t. So its closed loop transfer function is, so let's convert it into S domain. So if you convert it into S domain, so that will be equal to minus 1 by S plus 1 whole square plus 2 divided by S plus 1. So the take the LCM, so plus 2 into S plus 1. So that's equal to minus 1 plus 2s plus 2 divided by s plus 1 whole square. And that is equal to 2s plus 1 divided by s plus 1 whole square. So this is the closed loop transfer function. So 2s plus 1 divided by, so option B is the correct answer. Okay, next MCQs is, what is the open loop DC gain of a unity feedback control system having closed loop transfer function is given to me, and closed loop transfer function that is given to me, and that is s plus 4 divided by s square plus 7s plus 13. So here this is the unity feedback. So my HS will be equal to 1. So your GS divided by 1 plus GS will be equal to S plus 4 divided by S square plus 7S plus 13. So do cross multiplication. So your GS will be equal to S square plus 7S plus 13. That is equal to S plus 4 plus GS is equal to S plus 4. So your GS will be equal to S square plus 7S minus S. So this will be 6S plus 13 minus 4. That will be equal to 9. And that is equal to S plus 4. So your GS will be equal to S plus 4 divided by S square plus 6S plus 9. So for DC, my S will be equal to 0. So your DC open loop DC gain will be equal to 4 divided by 9. So option D is the correct answer. Okay, next MCQ is, the impulse response of a system is Ct is equal to minus t e power minus t plus 2 e to the power minus t. Its open loop transfer function is, so let's convert it into the S domain. So this will be equal to minus 1 divided by S plus 1 whole square plus 2 divided by S plus 1. So that will be equal to, your CS will be equal to minus 1 plus 2 into s plus 1 divided by s plus 1 whole square. So that will be equal to 2s plus 1 divided by s plus 1 whole square. This is your CT. So the let's convert this transfer function into open loop transfer function. So as this is gs divided by 1 plus gs into hs, that is 2s plus 1 divided by s plus 1 whole square. So this is unity feedback, so this will be equal to 1. So my gs times s plus 1 whole square, that is equal to 2s plus 1 plus 2s plus 1 whole gs. So this will be equal to gs will be equal to s square plus 2s plus 1 minus 2s minus 1, that is equal to 2s plus 1. So your gs will be equal to s square. This 2s will cut out by this 2s plus 1 will cut out by this one. That's equal to s plus 1. So your gs will be equal to 2s plus 1 divided by s square. So this is the final answer. So 2s plus 1 divided by s. So option A is the correct answer. Okay, next MCQs is certain control system has input ut and output ct. If the input is first passed through a block having transfer function e to the power minus s, and unity gain is applied to the system, the modified output will be. So let's suppose that this f into s is the block gain. This is my block gain. Let's suppose this is my block gain. Then your cs will be equal to your fs block gain times input function, which is rs. And if the input function is passed through a block having transfer function e to the power minus s, then your output c to the power ms will be equal to input function rs dot e to the power minus s dot fs. So your cms will be equal to fs into rs, that's equal to cs into e to the power minus s. So now taking the inverse Laplace transform. So if you take the inverse Laplace transform, so your Cm to the power t will be equal to C into t minus 1 dot u into t minus 1. So this is the final answer. So option B is the correct answer. Okay, next MCQs is lead compensator is used to improve transient response, steady state response, both 1 and 2, none of these. So actually your lead compensator is used to improve the transient response, and lag compensator is used to improve the steady state response. For this we use lead compensator, and for steady state response we use lag compensator. And there is also another type of compensator, that is the lag lead compensator, or you can say the lead lag compensator. This compensator improve both transient and steady state response. Okay, so this is the end of this tutorial. Thanks for watching. Allah Hafiz.